All right, so first things first, we're going to go over our warm-up. We have review from what we did on Tuesday. It says write the name or formula for each compound. And so for each one of these, we are going to either name or write the formula. For number one, it says hexaboron silicide, right? And so what is the symbol for boron, guys? B. And then what is silicide? Silicide. It's Si, right? It's just silicon. And then how many borons? 6, right? Because we have hexa, we know it's 6. Okay? Number 2, we have phosphorus. The symbol for phosphorus is P. We only have one. And then we have iodine. The symbol for iodine is I. And we have tri, so that's how many? 3. And then number 3, B is boron. We have 2, so that's what? Di. And then Si, once again, is just like up top. It's going to be silicide. Okay? So just to kind of review what we looked at yesterday. Today we're going to take a look at electron dot formulas. And so go ahead and take out worksheet 24. You got it on your way in. Worksheet 24. We skipped worksheet 23 because worksheet 23 is going to be the lab handout that I'll give you guys later on in the class. Okay, so 23 is that lab handout. So we're going to look at electron dot formulas. If you remember back to ionic bonding, guys, we did Lewis dot structures. Everybody remember those? Lewis dot structures was the symbol for the element with dots that represented valence electrons around it. Well, for ionic compounds, it's a little different, okay? Because we have double bonds, we have single bonds, we have triple bonds, right? And so there's a 5-step process that I like to use to go ahead and do electron dot formulas, and that's what we're going to look at today. And so the 5 rules for doing electron dot formulas. The first thing you're going to do is check your oxidation numbers, okay? I know it's been a while since we've talked about oxidation numbers, but oxidation numbers are just the green sticky notes on the top of the periodic table, okay? And so when we ask for oxidation numbers, just look at the top of that group and it'll give you the oxidation number. Part 2 says whichever one has the highest oxidation number, we put that element in the center, okay? Part 3, we make it fit like a puzzle. So if you remember back to those shapes we did on Monday, right? We had tetrahedral, we had trigonal planar, we had bent and linear. And so think about that. We want to spread out the elements as far apart as possible around that central element, okay? And then part 4, we check our bonds. And part 5, we check our electrons. How many valence electrons does each element want? Anybody remember octet? It's 8, right? And so they want 8 valence electrons, and so that's what we're looking for. There's only one exception, and that's hydrogen. Hydrogen just wants 2, okay? And so here's a couple side notes. Go ahead and jot this down on worksheet 24. This is important. If you don't get this, then you won't get the other stuff, okay? And so a dash is a bond, right? We call that a bond. So anytime you see a dash that looks like this, we consider that or call that a bond. Okay? Oxidation numbers are going to equal the number of bonds that are formed. Okay? Or the number of dashes that are formed. Right? So oxidation number equals the number of bonds. And then a dash is the same thing as 2 electrons when we're counting electrons. Okay? And so you want to kind of keep in mind and remember that a dash is the same thing as 2 electrons one way to help you remember that, if you put a dot on each side of the dash, right, you have two dots equals a dash. Okay, all very important stuff to remember whenever you are doing this stuff. So a dash is the same thing as a bond. Okay, the oxidation number is the number of bonds, and then one dash is the same as 2 electrons. As I mentioned before, some of you guys will really like doing this. Once you get the hang of it, it's 5 steps, so once you get the hang of it, you really can just look at it and figure it out pretty quick. Okay, we're going to do a lot of practice today because I want you guys to get the hang of it. All right. And so, first example. The first example is already done for you on your paper. Okay, I just want you to look up here and follow along. That way you kind of get an idea of how to do it, right? So just pay attention to the board. So we have CF4, okay? Our first step is to check our oxidation numbers, okay? So if we look up top, the oxidation number for carbon is 4. So I'm going to write that on top of carbon. And then the oxidation number for fluorine is going to be 1. Everybody see that? So oxidation number for carbon is 4. Fluorine is 1. We just find that at the top of the periodic table, the green sticky notes. So that's our first part, checking our oxidation numbers. Okay. The second part says we put the highest one in the center, right? And so of those two, which one's higher? Carbon, right? So carbon's going to go in the center. That's going to be our second step. Step 3 says make it fit like a puzzle, right? And so when you put your other elements, you just want to spread them out around it as far apart as you possibly can. And so I'm going to put my 4 fluorines around the carbon. And then we check our bonds, okay? What's important to remember, guys, your bonds are the same as your oxidation numbers, right? So carbon is going to want to have 4 bonds because the oxidation number for carbon is 4, okay? And so carbon is going to have 1, 2, 3, 4 bonds to fluorine, okay? 1, 2, 3, and 4. And then fluorine, each fluorine is going to want 1 bond, okay? And so if you look, each fluorine already has 1 bond, right? Because we put those bonds in for the carbon. So that's what I mean by check your bonds. Use your oxidation numbers to figure out how many bonds you need. The last step, we have to make sure that each element has a full octet, okay? And so we have to make sure each element has 8 electrons. Here's an easy way to look at it. That carbon, each one of those dashes is 2 electrons, right? So I'm going to put a dot on each side just to kind of help me count up my electrons. And so that carbon has 2, 4, 6, 8 electrons. Everybody sees that? 2, 4, 6, and 8. Okay? And so since carbon already has 2, 4, 6, 8, it's happy. Okay? Now fluorine only has 2, right? It only has those 2 electrons. And so fluorine's going to need to have 6 more in order to have 8. And so each fluorine, I'm going to have to add 6 more electrons so that it has a full octet and my electrons are all good to go. Okay? And so now my electrons, I can check that off. Okay? So just to kind of backtrack through what we did. Oxidation numbers, write it on top. Okay? Put the highest one in the center, then spread out all the other elements around that central element. And then we check our bonds. However, whatever the oxidation number is, that's how many bonds that element wants. Once we have our bonds right, we check for our electrons. Each element wants to have 8 electrons. And just remember that a dash is the same thing as 2 dots. Okay? All right, so we're going to move to the right side of your paper and look at those examples. So moving to the right side of your paper, you see the column that says valence electron, guys? you can scratch that column out. So there's a different way of doing this where you use the valence electrons. I don't like that method. So just draw a line through or scratch through the valence electrons column on your paper. And so we're going to start with CO2. Okay, we need the oxidation numbers for CO2. The oxidation number for carbon is going to be 4. And the oxidation number for oxygen is going to be 2. So which one's going to go in the center? Carbon's going to go in the center, right? Because carbon is the bigger oxidation number, or has the bigger oxidation number. And then we'll put our oxygens around the carbon. By the way, guys, you should be writing this in that last box where it says electron dot formula on your paper. So we made it fit like a puzzle. We put our oxygens there. And then we check our bonds, okay? Whatever that oxidation number is, that's how many bonds that element has to have, okay? So we'll start with carbon, right? Carbon needs 4 bonds. So if I put a bond in between each of the carbon and oxygens, then it only has 2 bonds, right? I still need 2 more bonds. Remember that we have single, double, and triple bonds. So in order to get carbon up to 4 bonds, we have to add another bond between each of the carbon and oxygens, right? So now carbon has 1, 2, 3, and 4, right? 1, 2, 3, and 4 bonds. Okay, everybody see that? Now, our oxygen, we need it 2 bonds, and it has 1, 2, 1, 2 on each oxygen. Remember, the bonds are shared between the 2, right? So we count them for both. So our bonds are now good to go as well. Our last step, we check our electrons, okay? Remember that a dash is the same thing as 2 dots, our 2 electrons. And so if we count our electrons for carbon, remember we want 8, and it has 2, 4, 6, 8, right? Because each dash is 2 electrons. And so carbon's happy. It already has 8. But oxygen is not happy. It only has 2, 4, right? So how many more electrons does oxygen need? It needs 4 more electrons. And so that's what we're going to do. We're going to draw in 4 more electrons on each of the oxygens so that now it has a full octet. The electrons just go in pairs around the element. Okay, depending on how many you have, kind of depends on how you want to distribute those around it. All right. Questions, guys? So remember, right? Biggest one goes in the middle. Oxidation numbers are so important here. Okay? Oxidation numbers are so important. All right, let's look at the next one. The next one is NH3. Oxidation number for nitrogen is going to be 3. Oxidation number for hydrogen is 1. So which one goes in the middle? Nitrogen goes in the middle. Okay. Then we're going to put the hydrogens all around it. And so I'll just draw in my hydrogens around the nitrogen. Next, we check our bonds, right? How many bonds does nitrogen want to make? It wants 3 bonds, okay? And so 1, 2, and 3. And then if we look, our hydrogens are now happy, right? Because they each have 1 bond. Now, remember I said hydrogens are exception, okay? So hydrogen is the only element when you're doing this that only wants 2 electrons, okay? And so if we look and we're checking our electrons, each hydrogen already has 1, 2 electrons. So each hydrogen is already complete. Everybody see that? Nitrogen, on the other hand, only has 6. So we need how many more? We need 2 more. Okay? And so 2 more electrons, we'll just put them on top. That's going to complete the octet, or all 8 electrons for the nitrogen. So we put our biggest one in the center. We spread the others out around, put our bonds in based on our oxidation numbers, and then we put our check our electrons, right? Hydrogen just needs 2. All other elements need 8 electrons. Right. Next example, CH4. Okay. And so once again, our oxidation numbers, it's going to be 4 for carbon and 1 for hydrogen. So carbon's going to go in the middle here. We're going to spread our hydrogens out around it. How many bonds does carbon want? 4 bonds, right? Because it's an oxidation number of 4. And so I'm going to go ahead and put in my 4 bonds for carbon. And so if we look, carbon now has 1, 2, 3, 4 bonds. Each hydrogen has 1 bond. And then we count electrons. Each hydrogen has 2, right? 1, 2. And then carbon is going to have 2, 4, 6, 8, right? So our bonds are good and our electrons are good. This would be our electron dot structure for CH4, which is just methane. Next one is C3H8. So oxidation numbers haven't changed. It's still 4 and 1. Now this one's a little different, right? I have 3 carbons, okay? This is what we would consider in biology like a carbon backbone. You may have heard that before, you may not have, okay? And so what's happening is the 3 carbons are actually going to be all together in the center, and all of the hydrogens are going to be around the carbons. Does that make sense? And so if you have an element like carbon, okay, where you have the highest oxidation number, but you have multiples of it, then you're going to put them all in the center and then just space out your hydrogens around it. Okay, and this is where you really have to think like a puzzle solver, right? I have 8 hydrogens, right? So they're going to fit all around those carbons. Okay, so that's 8 of them. Now, it might be easier to go ahead and start with our bonds for hydrogen, right? Hydrogen wants 1 bond to each of them, okay? So that's what I'm going to do. I'm going to put a bond from each hydrogen to a carbon to start off. So my hydrogens are happy, okay? And then if we look at the carbons, each carbon wants 4 bonds, right? Right now, each carbon, well, this carbon, right, has 1, 2, 3 bonds. So how many more does it need? Just 1, so we'll put that bond there. That means the next carbon now just has 3. It needs 1 more, so we put that bond there. And now each carbon has 4 bonds. Each hydrogen has 1 bond, okay? And if we count our electrons, each hydrogen has 2, and each carbon has 2, 4, 6, 8, right? 2, 4, 6, 8, 2, 4, 6, 8. Everybody's happy. Okay? So the only difference here is our carbons are in kind of like a carbon backbone configuration where all of the carbons are lined up and the hydrogens are spread out around it. Okay, moving on to the next one, last one on the front of 24, C2H4. C2H4. So once again, carbon has an oxidation number of 4. Hydrogen has an oxidation number of 1. So our carbons are going to go in the center, and they're going to go next to each other. And then we have 4 hydrogens to spread around. Okay, so I'm going to give each carbon 2 hydrogen. We're going to put in our bonds for hydrogen, so each hydrogen gets a bond to carbon. And then if we look at our carbons, right, they need 4 bonds. Right now they have 2. So if we connect them, right, they're still only at 3 bonds. Does everybody see that? And so once again, you have to remember, we can make what's called a double bond, right? And so in order to get it to our 4 bonds that we need between those carbons, or on that carbon, we have to put a double bond, right? So carbon now has 1, 2, 3, 4 bonds, right? And each hydrogen has 1. Electrons are good, right? Carbon has 2, 4, 6, 8, both of them, and each hydrogen has 2. All right, so here's what we're going to do. If you have scratch paper in your binder, go ahead and take it out, okay? If you have scratch paper in your binder, go ahead and take it out. If you need scratch paper, go ahead and put your hand up, and I'm going to hand out some scratch paper for you. Keep your hand up until you get your scratch paper, okay? Scratch paper. So the best way to get this down, guys, is to practice, okay? And so on your scratch paper at the top, go ahead and jot down electron dot practice, okay? And we're going to work some together just so that you can try it on your paper, right? And then we'll go over it. That way you know if you're doing it right or if you're not quite doing it right. Once again, the best way to get this is to practice. So go ahead and write down electron dot practice on your paper. Okay. All right, so your first one, GeI4. Go ahead and jot that down on your paper, and then take a minute to go ahead and go through those 5 steps and draw the electron dot formula for this one. I'll give you guys a couple minutes. All right, let's take a look at this one together, okay? So we have germanium, right? Germanium is that first element. And so our oxidation number for germanium is going to be 4. Our oxidation number for iodine is going to be 1. So which one goes in the middle? Germanium does, okay? So Ge goes in the middle. And then I'm going to spread my iodines all around the Ge. Now, it doesn't really matter where you put your iodines, okay? As long as they're as far apart as they can be from each other, right? So as long as you spread them out, that's fine. Germanium needs 4 bonds, right? Each iodine needs 1 bond, and so we'll connect them with single bonds. And so our bonds are already taken care of. Iodine wants 1, germanium wants 4. The only thing we have left to check is our electrons, right? Germanium has 2, 4, 6, 8. But the iodines only have 2, right? They need 8. So they need how many more? They need 6 more, okay? And so that's what we have to draw in. 6 more electrons around each iodine to complete the octet. Okay, so germanium goes in the middle because it's the largest oxidation number. Put the iodines around it, put your bonds in, and then we have to fill the octet of the iodine, so we have to put 6 additional electrons around it. Okay? Next example, Pi3. Go ahead and jot down Pi3. I'll give you guys a minute or so to get this one done on your paper. Okay, so let's take a look at this one. Phosphorus has an oxidation number of 3. Iodine has an oxidation number of 1. And so phosphorus is going to go in the middle. We're going to spread our iodines all around the phosphorus. And then if we look, phosphorus wants 3 bonds, iodine wants 1 bond, and so we'll put a bond in between each of those. Okay. Now our bonds are good, right? Phosphorus has 3, each iodine has 1. We just have to check our electrons, right? Phosphorus only has 6 electrons. It has 2, 4, 6. Okay, so it needs 2 more. So I'm going to put 2 electrons on top of that phosphorus. And then our iodines are in the same shape they were in the example before this one. They need an additional 6 electrons to complete their octet. And so I have to put in 6 around each of the iodine. So this would be the correct electron dot structure for Pi3. All right, let's try this next one. H2O. H2O. Do the same process, put your oxidation numbers, and follow those steps. Okay, so the oxidation number for hydrogen is 1. Oxidation number for oxygen is going to be 2. So which one goes in the middle? Oxygen goes in the middle. Okay, we'll put our hydrogens around it. And then we look at bonds, right? Oxygen wants 2 bonds, hydrogen wants 1 bond. And so we put a bond in between each of those. Our bonds are good, right? Oxygen now has 1, 2, and each hydrogen has 1. And then we just check our electrons. Our oxygen only has 4, right? It needs 8, so we have to add 2 additional electrons on top and bottom, right? So now it has 2, 4, 6, 8, and each hydrogen has 2, so our hydrogens were already happy. This would be the electron dot formula for H2O. Next example, C2H2. Try this one. Give you guys a minute or so to do that. Okay, so for this one, carbon is oxidation number of 4, hydrogen is 1. So our carbons are going to go in the middle. Remember, if there's multiple, we're going to put them together in the middle, right? And then we'll space out our hydrogens around it. And for this one, I only have 2 hydrogens, so I'm going to put 1 on each side. Okay? Now, the carbons are going to want 4 bonds. The hydrogens are going to want 1 bond, right? So I'm going to start by putting my 1 bond to each hydrogen. That's all that I can put there. Okay? But my carbons still need 3 additional bonds, right? So in order to make this work, I have to put a triple bond in between the 2 carbons, right? So 1, 2, 3, my triple bond. Now if we count our bonds, carbon has 1, 2, 3, 4. Same thing over here, 1, 2, 3, 4. And each hydrogen has 1. This is the only way that this works, okay? We check our electrons. Hydrogen has 2, and each carbon has 2, 4, 6, 8, and we're happy. Okay? It's kind of like a puzzle. You have to figure out how many bonds are going to go to make it work. If you ever get to a spot where your 4 and your 1 for your bonds is not working, that means that you didn't do something right. Okay? So just be careful with that. All right, so next example, CH2F2. Try this one. All right, so let's take a look at this one. Our carbon has an oxidation number of 4. Our hydrogen, 1. And then fluorine, that's a little different, but it also has an oxidation number of 1. So carbon's going to go in the middle here, right? Then we'll have hydrogens around it, and then we'll have fluorines around it. If we look at our bonds, each hydrogen wants 1, each fluorine wants 1, and then the carbon needs 4 bonds. And so we're just going to put a bond in between each one of those. And that satisfies our bonds, right? Carbon has 1, 2, 3, 4. Each hydrogen has 1, and each fluorine has 1. Then we just have to check our electrons. Hydrogen's happy, carbon's happy. Our fluorines are not, right? We still need to have more, and it's actually 6 more, right? So each fluorine, you put an additional 6 electrons around it so that you have a total of 8, okay? And now your fluorines are happy with 2, 4, 6, 8 electrons around each one. All right. Next one, HCN. I'll give you guys a minute or so to do this one. Okay, so our hydrogen has an oxidation number of 1, carbon is 4, and then nitrogen is 3. Okay, so we put our carbon in the middle, hydrogen on one side, nitrogen on the other. Our hydrogen wants 1 bond. Our carbon needs 4, and our nitrogen needs 3. Okay, and so how many bonds have to go in between carbon and nitrogen? 3, right? So it's a triple bond. That's the only way this works. So now our bonds, we have 1 hydrogen, we have 1, 2, 3 for nitrogen, and carbon has 1, 2, 3, 4. Okay, then we check our electrons. Carbon and hydrogen are happy. Nitrogen still needs 2 more, right? So we put 1, 2 on nitrogen, and that's going to be the structure for HCN. Okay, so on your way in, you got worksheet 26, okay? And then the back of worksheet 24 is worksheet 25. So you have most of the rest of the class to work on 25, right? Worksheet 25 is just Lewis dot structures, the same thing we just did, okay? And then worksheet 26, if you look at that one real quick, if you look at the front, you're just naming and writing formulas, okay? So a little more practice with that. And then on the back, some more practice with drawing electron dot formulas, okay? And so you still have quite a bit of time. You have way more than enough time to get it done, okay? And so use your time wisely. Remember, you do have a binder check next Tuesday. And so get those done, 25 and 26 completed. Towards the end of class, I will hand out your lab handout and tell you what you need to do before the lab to make sure you can participate in the lab on Friday.